Let's travel to Thailand to understand how politics and international advocacy networks prevented Hawaii's success from being replicated in this country, where papaya is a culturally important staple food. Outside of the tropics, papaya is a rare delicacy, but in the country of Thailand, papaya is eaten both in its highly nutritious ripe form as well as in the more commonly form of green papaya salad, or somtam. Somtam is a typical lunch food served in food carts on the busy streets of Bangkok, as well as eaten by farmers and field laborers working in the rice paddy fields in the countryside. Rice farmers often keep a few papaya trees near their paddy field for easy access to a somtam snack for their midday meal. They usually travel to their paddy fields in the morning with a small basket of sticky rice, the perfect accompaniment to somtam. Over 90% of papaya produced in Thailand stays in Thailand. Only a small percentage is exported, usually as one component of canned fruit salad destined for the Middle East, China, or Europe. So most papaya growers should not be strongly influenced by trade issues. Papaya ring spot virus was first reported in Thailand in 1975 and has spread throughout the country. It is the biggest threat to papaya production in Thailand, which is why the early success in Dennis Gonsalves' lab looked so appealing for Thai scientists struggling to find a solution. One scientist, Vilai Prasartsi, a plant pathologist working for the Thai Department of Agriculture, was one of the first to reach out to Dennis and set up a collaboration to work towards saving Thailand's papaya. In 1995, two Thai researchers traveled to Dennis Gonsalves' lab at Cornell University to create papaya ring spot virus resistant lines. Two Thai preferred varieties, much larger and more elongated than the Hawaii preferred varieties, were transformed using microprojectile bombardment, informally known as the gene gun. The construct inserted into the papaya contained a non-translatable coat protein gene isolated from a Thai strain of the virus. Because the coat protein is not translated from DNA to protein, no detectable amounts of foreign coat protein are present in the transformed papaya. In other words, no new protein or substance is produced. The technology was very promising, and it stood up to all of the classical arguments against genetic engineering. It was publicly funded, it solved a pressing agricultural problem, was royalty-free, the seed could be saved, and it was a Thai initiative meant to benefit Thai farmers. Precisely why international anti-GMO advocacy networks were so determined to bring this project to a halt, which they did. July 27, 2004 was doomsday for GMOs in Thailand. On that day, international advocacy networks changed the course for genetic engineering in Thailand. They traveled from the capital city of Bangkok to the papaya field trial in the rural northeast. They trespassed the research station where the papaya was undergoing testing, and in front of previously invited media, they threw the research station's papayas into biohazard waste bins, claiming their danger in front of cameras keen to capture the event. There, Greenpeace charged that genetically engineered papaya seed had been distributed beyond the confines of the field trial under the negligence of the Department of Agriculture, and they presented evidence of the papaya being grown illegally by farmers in 37 provinces around Thailand. The Department of Agriculture responded by charging two Greenpeace campaigners with trespassing, theft, and destruction of property, but the activists were later acquitted. Soon after, under pressure from claims by anti-GMO advocacy groups, the Ministry of Agriculture ordered the destruction of the ongoing field trial at the research station, and soon all field trials in the country, bringing research on all GMO crops to a standstill in Thailand.